Hello everyone, Vexento here, back with another tutorial video. In this tutorial, I'll be showing you how to create your own particles and mess with the particle system using Snowstorm application or website. So without further ado, let's get into the video. First of all, what you want to do is you want to head over to snowstorm.app. Now you can open this up in any web browser and it'll work. So if you type in snowstorm.app, you can see that you have the link, or you will just navigate to this application. I will be leaving a link down in the description below for this application, but now you can just type in snowstorm.app and you can head over to this website. Now once you're in this website, what you want to do is you want to set up an identifier. Now with the identifier, this just makes it so your particle is unique to any other particle names on a resource pack. Because particles are actually dependent on the resource pack, you don't actually need a behavior pack. So just to keep that in mind, make sure you are defining this as a resource pack identifier type of name instead of depending on the behavior pack. So what I'm going to do is I'm going to give my identifier a name of sign ... or colon example, and this will be what I will use to the particle command to use in the particle command. Next is everything else. So the emitter, which allows us to define a rate of how many particles spawn pretty much every tick, I'm pretty sure. And you can see down here on the bottom right, we've got 3p and 4p. So at a rate of 4 particles, we get around about 3 to 4 particles per tick. So if we were to change this up to 20, we can see that it's gone up by a bit. However, some particles are actually being killed off, so it is a bit lower number, but however, it is doing it at a rate of 20 particles per tick. Next is the appearance of the particle. Now this just defines the size of the particle. You can just leave this at 0.2, which is basically the default. However, if you want it to mess around with this, you could change it to blend, where it will blend with other particles and allow alpha materials through, so you can see through the particle. Otherwise, you can just leave it at alpha test and it will just basically be an alpha test of between 0 and 1, so there is no transparency at all. Next is the motion, and this just allows you to sort of set a random motion on the particle. So for now I'm just going to set this to 2, and you can see here that the particles have started to move in random directions. Now you can actually change this, so instead of having speed of anything, you can just set this at 0, and then if you want this to have a set speed on a certain axis, what you can do is you can set the acceleration. So we can set this to 2 on the y-axis, and we can see that the acceleration is going up. So if we were to set this to 4 here, you can see most of the particles are actually going up, but however some are going down and then they're slowly going up. So this is quite useful for a lot of particle simulations that you might want to do, but this is sort of just the basics of how a particle system works. So with that out of the way, we can look at the other parameters or components that we can actually use. For example, we can use the rotation, so we can actually rotate the particle. However, since I'm not really going to show that, I'll just leave this as blank. But you can mess around with this and you can hover over certain fields and it will tell you, for example, start rotation. If I hover over this, it says specifies the initial rotation in degrees. So this is quite useful for knowing how particle systems work. So next thing that I'm going to show you, which is the next important thing, is the max age. And this just defines how long the particle will live for before it gets killed off. For example, you can see that a particle is getting up. You can see a particle is actually alive for a time and then it disappears. That's when it reaches its max age. So if we set this to 0.2, we could see that the particles are a lot less in numbers. But if we were to set this to 2, example 2, it accelerates. Well, there's a lot more particles outwards that last for a long time. And of course, if you want to reset the particles, you can just click on this play button and it will reset the entire simulation for you. And of course, you can have a couple of other parameters that you can use. I won't go into in-depth into this, but this is basically what the lifetime does, which is find how long a particle should live for, or if it reaches a certain condition. So for now, I'm just going to leave this at 1, which is the default. Next, what I'm going to show you is the texture. Now with the texture, you can specify a UV or you can specify a single texture file. Now in Minecraft, most of the time, they actually use a file called Particles.png. Now if you want to have access to this Particles.png, you can actually download it from the Bedrock Samples resource pack. I will be leaving a link in the description below. Now the great thing about this is you don't need to have this in your resource pack because it's already part of Minecraft. So all you have to do is just define the path for it, which it's already set here, which is textures / particle / particles. And we can see here that it's actually given us the default particle texture for us. Now the next thing that you might want to know is picking a certain particle from this image. Now to pick a certain particle from this image, what you can do is you can check the size of the image. So in the particle image, the texture size, or the size of the image, is actually 16 by 16 pixels, or 16 by 16 slots. And keep this in mind, this is actually useful for what we're going to do next. And what we're going to do next is we're going to define the UV size. Now with the UV size, basically pretty much divides 16 by the UV size, and the UV size on a 16 by 16 grid is 1. As you can see, as soon as we set this to 1 and 1, we can see that the particles are now selected on the very first slot. So this is basically what allows us to specify each texture in a UV map. Next, what we're going to do is we're going to select a particle. And to do that, we can just use the UV start. Now with the UV start, you start from 0, then count up to 15, because the texture size is actually 16 by 16. We have the max value of 15 because 0 is actually a number or a count. So right now this is actually set at 0, 0, even though there's not really anything in there at the start, but if we set this to 0, 0, nothing really changes. So if we were to select the bubble, which is at 0 on the x coordinate, and 1, 2 on the y coordinate, and as you can see, we have got ourselves a bubble. So that's pretty much how the particle system, or the texture in the particle system, actually works. And next we can choose the color and light, and this just basically allows us to set a color value on the actual particles. And of course you can actually change this, so we can have a bit more of a transparent particle, and we can change it so it actually acts with the environment. So if the particle was inside a dark cave, then it would be a dark particle. But of course you can turn that off and it will work independently. So that's pretty much all you need to know about how textures in the particles, or how to change the appearance of the particle. So now onto the more difficult part, or the more advanced part. What you can do is you can actually use molaying to create some interesting motions. So what I'm going to do is I'm just going to reset the speed on this and reset the acceleration, so we have nothing. And what I'm going to do is, under the help tab, we can see molaying sheet. And if we click on this, we can see we get a couple of variables that pretty much explain what each variable does, and we get a couple of math operations. So you could do a lot of things. For example, you could have a random mathematic value. So for example, we can see here, we can have math.random, and that will give us a value between the lowest value that we input and the highest value. So as an example of what you would use molaying for, I'm going to show you a small, basically a radial mathematical operation that can pretty much introduce you to some interesting concepts. So we're just going to exit out of that. Next, what we're going to do is we're going to click on, I believe it's under appearance or motion. Nope, never mind. It might be under spawn shape. Here we go. So spawn shape allows us to actually define the emitter's shape. Right now it's set to a point, so we just have a point of at 0, 0. However, we can change this so we are filling in a molaying variable. Now with the offset, we can actually just offset the particle system, so it spawns particles up here. But we're going to do something interesting with the molaying, and that is we're going to input a radial mathematical operation, and we're going to use the cosine operation to actually move this emitter around while it's running. So to do this, what I'm going to do is I'm going to select this middle value, or the y value, and what I'm going to do is I'm going to select this input value. And this is just a longer version of what I just selected. So what I'm going to do is I'm going to type in the mathematical operation, which is math.cos and bracket. Then we're going to put in variable, or v dot emitter, because we want to move the emitter, not the particle. Emitter underscore age, so we're getting the age of the emitter while it's running, divided by v.emitter underscore lifetime. And this just gives us the max amount of time the emitter has. Then we're just going to times this by 180, so we're doing 180, and we can see we have got some interesting results here. And then what we can do is we can do a little bit more with this, so we can do times by 10, so we get a bigger sort of area. And then of course we can sort of change how this works, so we can have like 30 particles and not real a lot changes. So we might have to change the lifetime of the particle. So in max age, we'll set this to 0.2. And if we reset the particle, we can see that we have got some more of an interesting result. And of course you can change this, so we can use math.sine. And we have got a bouncing particle. Of course, if we use tan, which I'm pretty sure might not work, yeah, it seems like it doesn't seem to work. So math.sign and math.cos is probably the best that you can mess around with. Now we can change this so we have a bit of a smaller particle. And then we can also change this value inside here. So we do a full 360 degree rotation. So we go up and down. And then what we can do is we can actually copy this and put it in the X value. And we can get a diagonal type of mathematical operation. Now, if you don't want a diagonal, we can actually make this a circle. And to do that, we just use the cosine, if I can spell correctly. And we can see here that we've got a spinning circle. And of course, if we want to go the other way, we can do -2 and we go the other way around. So this is just some pretty basic maths or general maths that you'll learn. And you can actually use this in the particle system, which is useful in some cases. However, if you don't want to use math, the particle system actually gives you something called curves. And with curves, what you can do is you can actually set up a graph so you can have some interesting, well, a bit more of an interesting result instead of having to write out the mathematical operation. So what I'm going to do to actually show how this works is just delete that, delete these two. So we've got nothing. And then what I'm going to do is I'm going to change the variable name to something called test. It doesn't really matter what you name this, just make sure you have the variable as the start. And then the mode, we're just going to leave this at linear. Now if you were to choose something like CatMoRom, it changes the graph. But for now, we're just going to leave this at linear. Next, we can change this to emitter. So we're changing the position of the emitter. So we do emitter_age, and then the range or the horizontal range is the emitter lifetime. And that's basically what you'll most commonly see with particles, because of how the emitter lifetime and emitter age are pretty much the most common things that you might see in pair with each other. So with that filled in, what we're going to do is we're going to copy variable.test, and we're just going to put the y-axis on the point. And as you can see, we have got a moving bubble column. Now if you wanted to change this, we can change it so it's a bit higher. And of course we can do a bit more. And of course we can add some more points, so we can have some more interesting results. And you can just sort of mess around with this and have what you want. And of course we can change this to Bezier, so we have a bit more of a bigger bounce, and then it slowly goes down. And then we can just sort of change this so we have a bit more of an interesting result. Maybe it's a bit too fast. And oops, I apparently have deleted it. So we'll just change this back. Quickly get this back. That is not supposed to happen. And then we just change this to emitter. And then we can change this to CatMoRom, so we have something interesting. Now, of course, this might not do much because of how sort of the CatMoRom works, so we might have to add another variable here. As you can see here, we've got a bit more of a smoother up and down motion. So we can change this so we have a bit more of an interesting result as well. And then we can just move this up or down. And of course we can go into the negative values, so we have it dropping down. And you can sort of just mess around with a lot of this stuff. And it's sort of a visual type of graphing, which is a bit more user-friendly. However, you do sort of need to know a bit about maths, about how this works. But that's pretty much all the particle system has to offer. Now you can have variables, so for example, when a particle is rendered or when a particle is updated, you can have variables that change as soon as these events are fired. But I won't go into detail about this. It's just sort of the same thing as the curves, except you just have a variable with a value. And then with the last one, we have the space. Now, the space is actually pretty simple. What this does is it just attaches the particle to an entity. But in the case of the particle command, it won't actually attach to an entity. So this is pretty much useless for the particle command. But if you were to set it on an animation controller that's attached to an entity or a block, you can set it so it has the same velocity as the entity, or the rotation, or the position. So that's pretty much how the particle system works. So now that we have pretty much the basics covered, what I'm going to do is I'm going to create a simple particle, or a simple custom particle, and then I'll show you how to import it into Bridge and then into Minecraft. So, with that being said, I will see you on the other side once I have finished making this particle. Once you are done creating your particle, what you want to do is you want to go up to the code tab up on the top right. And once you click on this code tab, it will give you a piece of code that you can actually copy and paste into Bridge. So what I'm going to do is I'm going to copy this and then head over to Bridge. And the great thing about the particle system is you don't need any experiments, just have a resource pack. And what you can do, you can go to More, New File, Particle, and then we just name this file Example, then we create the particle file. And what we can do is we can just remove all of this and paste the particle code in. And that is pretty much all you need to do. So let's head on over to Minecraft and see how this looks in game. So once you're in game, what you want to do is you want to use the /particle command to make your particle appear. Now, to actually use the /particle command, what you need to do is you need to remember your identifier for your particle. So mine is sign.example. And then in game, you just type in /particle, then the identifier of your particle. So sign.example. And then optionally you can set a position, but for now I'm just going to do the /particle sign.example. And as soon as I spawn this in, we can see that we've got sort of the particle. So just to make this a bit more visible, I'm just going to place this command block down, and then we just put in sign::example, and we can see here that we have got our particle. Now I'm just going to move this up a bit so we can see it a bit better. Ooh, that's a bit too high. Maybe we'll do 2 blocks. And yep, there we go. We have got our particle working. So, hopefully you learned a bit about how particles work and have an in-depth understanding of how it works. Now, if you are like a math nerd or something, you can do some pretty crazy particle experiments. But for those who don't really know, you can just use the curves and you could still get sort of the same achievements that you can get. With the math one, you can have, for example, reactive particles. And of course, you can have particles that have collision, so they can bounce on the ground. But that's pretty much up to how you want to do that. So with that being said, I will see you in the next tutorial. Bye!